Hey there, friends. It's Maverick from Arizona Science Center coming to you with another 12:30 Facebook Live here. Now, today we are going to be talking a little bit about some simple circuits and how circuitry works. And I know I talked about this, I think it was either last week or a couple weeks ago, a little bit, but we're going to expand on this a little bit. And we're going to make our very own flashlights with a couple little materials that you might have sitting around at home. But we're going to explore the concept of circuitry, and we're going to see how we can make that work. So the first thing I really want to talk about is how does a circuit work, and what is a circuit, right? How does electricity flow through an object? How do we turn a light on or turn a light off? How does that work? Does anybody have any guesses they want to throw into the comments here? I'll give it a little bit of time. How does electricity work? That's a very broad question. How does electricity work? How does a circuit work? What do we need to do? I'll give you a hint. Circuit sounds like the word circle. So I'm going to make this little circle here, but how does a circuit work? How does electricity move? Does it move in a straight line? Does it move in a circle? Does it move in a zigzag pattern? What do we think? I'll give you a little bit of time there. And then I'm going to bring this little thing out, which I don't know, some of you might remember this from last week if you saw it, some of you might not. But this is our little energy stick, so I'm going to show it off again to talk about circuitry. But basically the way this works, the way a circuit works is it needs to be a closed loop. It needs to be a full circle like this, right? It needs to be a closed loop. If it's open at all, the electrons don't pass through and you don't get any electricity actually flowing through. So like with our energy stick right now, Leah thinks that it moves in a zigzag. It can move in a zigzag. It kind of depends on what the shape of your circuit itself. So it doesn't necessarily have to be in a circle, but it kind of moves in a circle in the sense that it's one big loop. But it can be in a zigzag depending on the shape of the wiring. But the common thing that you need is you need to be able to close that circuit. So right now I'm holding this, nothing is happening. When I close the circuit, as the electrons flow through my arm all the way through my other arm and I close the circuit, we get power. The electrons flow all the way through my body into this, and it powers it up. It doesn't necessarily have to be this. It can be anything conductive. Let's touch it to this metal. While I'm holding the metal, holding this, touching it to the metal, it's also conductive, right? It needs to be something that can actually pass the electrons through. So with that being said, normally you have a positive side and a negative side. Positive and negatives in terms of chemistry, in terms of electricity, are very attracted to each other. The opposites attract, similar sides push away from each other. If you've ever seen a magnet and you try to put the same ends on two different magnets together, they typically will try to push away from each other. But that works with things like batteries, right? You have the positive side and the negative side. And you need a closed circuit from positive to negative to make your battery, or to power whatever you're doing, which is why you typically will have two in here, and they always go positive to negative on the bottom. But we're gonna make our own little flashlight here. I'm gonna give you the basic steps and then you can get fancy with it as we keep going. But I've got this little tube here, which is gonna work as the body of my flashlight. I've got two AA batteries here. There's other batteries that you can experiment with at home. You can try it with AAAs, you can try it with a D battery, you can try it with some other things. But you just need something that's gonna create that power. Then I've got some aluminum foil right here, which is gonna work as my wiring. And then I've got a little bit of tape. I've got just this little tape here you can use. You can use electrical tape, ideally is gonna be the safest, but this won't be producing enough heat to really do too much. But when you're doing it at home, if you're using a more powerful battery, you probably wanna use electrical tape just so it doesn't melt the tape or anything like that. But the first thing you're gonna wanna do is you're gonna take your batteries and you're gonna wanna put them positive to negative like this, right? Just like that, just like if you were putting batteries into a flashlight itself. You want that positive to negative. And what I like to do is I like to tape them together so that that positive and negative are pushed against each other really tightly so that they're always in contact with each other. And this can take a couple rounds of taping, but ideally you want it as tight as possible when you're making that seal. Ideally. Let me just go ahead and get that on there. Wrap that around. And then I'm gonna get another little thing of tape here. Go around again. But you want a nice tight connection so that connection is not broken and you constantly get it attached to our positive and negative ends. And that is how the electrons are going to flow from one diode of our LED light to the other. This tape is, it's another reason why I don't like this tape as much as electrical tape, but not everybody has electrical tape at home, so we're going to experiment with stuff we might have at home. But this tape loses its stick a little bit. So I've got those taped together, and we're going to take our LED bulb here, which these are pretty easy to access, but each side, there's one longer side and one shorter side. The longer side is the positive side, the shorter side is the negative side. The cool thing about these is you can adjust them out, you can bend them and flex them out. So I like to bend them out and just keep in mind which side you have it on. So I've got my positive side on this, and I'm gonna attach it to the foil because you want that connection to the foil because that is what's gonna conduct the electrons. And then you can take some tape and tape it to it if you want to make it extra sealed on there so it doesn't fall off. And then I like to twist this up to make it a little more like a wire. And then you're gonna do the same thing on the other side, but what's important to do is to not cross these over. You don't want the two wires touching each other, or else that's gonna confuse the circuit. The electrons are gonna kind of start flowing into each other instead of through the circuit if you've got the negative and the positive side touching each other, and then your circuit will not work the way you want it to. So I'm gonna tape these. This is really losing its stick here. Tape that just a little bit to there. Perfect, so now I've got positive and a negative side right there. And we're gonna test it out with our batteries here. And you wanna press these together. So you've got the aluminum touching each side. And when they're pressed together, as long as the connections are stable, you've got a light that should light up. If I were to turn this around, we'll test this out. I've got the negative side on the positive diode of the LED, the negative side of the battery on the positive side of the LED, and the negative side of the LED on the positive side of the battery. You notice that it doesn't light up. So if you notice that yours isn't lighting up, then possibly switch the direction of the batteries, because that could be what's impacting it. So now once you have that, that's when you can add the decorations. That's when you can make it fancy. So what I like to do is I like to do it kind of like this. And we'll test this out and make sure that this works right. But I put the LED or the foil in here, and I spread that out to the side so that ideally, once I get in there, they're not touching each other. So I kind of put them on each side. And then I'll have it, and you can adjust the length of your foil however you want, but I'll have it so the foil is towards the end, and I fold it out, and I'll tape my sides of the foil to each end of the light. And what I'll have, and I'm not going to tape it right now, but what I'll have is when I close one side, when I push down on one side, it'll create this flashlight. So then if I put a piece of glass or if I put a lens over this, it would actually act a little more like a traditional flashlight. So when I take hand off, when I press the button, close the circuit, we get our very own flashlight that we can actually use to light things up. And that's a fun little at-home flashlight that you can make just using some simple circuits. You can use aluminum foil, you can use some like copper wiring, you can use little LED bulbs, you can use bigger light bulbs, but different power, different batteries, different light bulbs require a different amount of power, so make sure you're careful and make sure you're paying attention to what the voltage of the light bulb is and what batteries you're using. But go ahead and experiment and test it out and see what different flashlights you can make at home. It'd be really fun. But thank you guys so much for joining us for another Facebook Live here with Arizona Science Center. Always, always, always enjoy it. Go ahead and check us out at azscience.org to see all the other stuff that we are offering here with Arizona Science Center. Or come in and visit us right here at the center since we are reopened. We'd love to see you all and come join us for just a fun day at the Science Center. So my name is Maverick. Thank you so much for joining us and have a great rest of your weekend, guys. Bye, everyone.